Hello students, welcome to our second lesson on trigonometry. I hope you are all doing well. Right. In our previous lesson, we introduced ourselves to the topic and we looked at definition of trigonometry. We looked at triangles. We looked at examples of triangles, properties of triangles, and finally we looked at parts of a right-angled triangle because we said that we are going to focus on the trigonometry of right-angled triangles. Okay, good. So with the parts of right-angled triangle, we said that the longest side, that is the side which always faces the 90-degree angle, is called the hypotenuse. And we said that the other two sides get their names based on the reference angle. So if this is the reference angle, then this side will be the opposite or opposite, and then this side will be the adjacent. But if this side is the reference angle, then this side will rather be the opposite, and then this side will be the adjacent. Okay, good. So that was what we looked at the last time we met. Now, in the definition of trigonometry, we said that it's a branch of mathematics that studies the relationships between the length of sides and angles of triangles. So in our case, we said we'll focus on the right-angled triangle. In this lesson, we'll look at these relationships. Okay, the relationships between the length of sides and angles of right-angled triangle. So let's begin our lesson. Now, relationships between the sides and angles of right-angled triangle. We'll focus on two main relations. We'll focus on two main relationships. One is between or among only the length of sides. So we'll consider relationships among only the length of sides. Then we'll look at the relationships between the length of sides and angles of a right-angled triangle. So the first relationship will be between or among only the length of sides. Okay, it will be among only the length of sides. And then the second one will be between the length of sides and angles. The length of sides and angles of a right-angled triangle. So let's look at the first one. So the first one is called the Pythagoras Theorem. The Pythagoras Theorem. Pythagoras Theorem. Now this one focuses only on the length of sides. Okay, it focuses only on the length of sides. And then the second one that we'll consider is trigonometric ratio. Trigonometric ratio. This one focuses on the length of sides and angles. The length of sides and angles. So these are the two relationships we'll consider in our study of trigonometry. Okay, Pythagoras theorem, which focuses on only the relationship between the length of sides, and then trigonometric ratio, which focuses on the length of sides and angles of a right-angled triangle. So let's begin with the Pythagoras theorem. Let's begin with the Pythagoras theorem. Okay, so assuming this is our right-angled triangle, okay, this is our right-angled triangle, right? This is our 90-degree, okay, 90 degrees angle. Now, if this side, let's say, measures 4, and then this side measures 3, and then this side measures 5, Okay, so let's label this one A, B, and then C. Now we have our right angle triangle. Now let's square the sides. So this side, if this is our reference angle, this side will be our opposite. So let's square that value. So 4 squared. Okay, then let's square this value to the adjacent value, 3 squared. Now let's also square the longest side, 5 squared. Good. So now what is 4 squared? 4 squared. Alright, so 4 squared is what? 16. So most students, they get confused. 4 squared is not 4 times 2. Okay, 4 squared is 4 times 4. So you don't say 8. 8 is wrong. 4 squared is 4 times 4. 3 squared is 3 times 3. So the answer will be what? 9. And then 5 squared is 5 times 5. So it will be what? 25. Good. So now let's look at something here. We have 16 here, 9 here. Now when we add 16 to 9, what will we get? When we add 16 to 9, what will we get? 25. Good. So it means that this 16 plus this 9 will be equal to what? 25. Okay, so going backwards, when we put a plus sign here and we put an equal to sign here, it means that when we square the opposites and added it to the square of the adjacent, we got the square of what? The hypotenuse. I hope you follow. So when we squared the opposite and added it to the square of the adjacent, it was equal to the square of the hypotenuse. Okay, so let's take another example so that we draw conclusions on this example. Then we'll focus on the general relation or equation for Pythagoras theorem. So let's look at another sketch. Okay, so if I have this right angle triangle, now this is my theta. This side is let's say 6, this is 8, this is 10. Okay, so let's square the sides. So opposite squared, which is 8 squared, plus adjacent square, which is 6 squared, and then let's also square our hypotenuse. So from what we looked at, this was the relation. Let's check whether it's true. So 8 squared will give us what? 8, 8, 64, plus 6 squared is what? 36. Okay, 36. So 64 plus 36, what will it be? It will be equal to 100. And 10 squared is also what? 100. I hope you get it. I hope you get it. Good. So now let's put all of it together. So from what we've looked at so far, you realize that when we square the opposites or the other two sides of the right angle triangle and we add them, it's equal to the hypotenuse, the square of what? The hypotenuse. So the hypotenuse squared is equal to the sum of the square of the other two sides. Okay, the hypotenuse squared is equal to the sum of the square of the other two sides. I hope you get it. Good. So generally, this is what the Pythagoras theorem says. If you have a right angle triangle, which is this side is C. Now, by convention, the side facing the C should also have a small letter C. Okay. Then, if this is our A, this side will have a small letter A. and then this our b will have a small letter b. So by convention, okay, this is how it should be. The side facing the angle should have a small letter of the value here. Okay, right. So now generally we saw that c squared in our case, so the c is the hypotenuse, is equal to a squared plus b squared. Okay, so c squared is equal to a squared plus b squared. So this is the general formula for Pythagoras theorem. So Pythagoras theorem, this is it. C squared is equal to a squared plus b squared. So in every right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. The square of the hypotenuse is equal to the sum of the squares of the other two sides. I hope you get it. Good. So now, from change of subject, make a the subject for me. When you make a the subject from this equation, what will it be? Good. So you realize that it will be a equals the square root, okay, a equals the square root of c squared minus b squared. So you maintain the a, then you send this b squared to the other side, okay, then you find the square root of both sides. What of b? So b will also be equal to what? Okay, so b will also be equal to the square root, okay, of c squared minus a squared. Then finally the c will be equal to what? The square root of a squared, okay, plus b squared. So students, you have to take note of these formulas, okay, these equations. So if you know this, you can derive the others through change of subjects. Okay, so this is what we call the Pythagoras theorem. This is what we call the Pythagoras theorem. Okay, Pythagoras theorem. Right. So I hope you get it and you realize there is a relationship among the sides, only the sides of a right-angled triangle. Okay, right. So now let's solve some questions based on the theorem. Let's solve some questions based on the theorem. Good. So this is example 1. We are to find the value m in the following diagram. So find the value m in the following diagram. Alright, let me just do the first one and then you do the other two as an assignment. Okay, so I'll solve this first one, then give the other two to you as an assignment. Alright, so let's look at how we'll solve this one. Now we're given a right angle triangle and this is the hypotenuse. Based on this reference angle, this is the opposite and this is the adjacent. Okay, so from our lesson right now, from Pythagoras theorem, we can have a relation between the hypotenuse, opposite, and then the adjacent, and then that equation or relation will help us to find for what? For m. I hope you get it. Alright, so we know that m squared will be equal to what? 4 squared plus what? 3 squared. Then when we find the square root of both sides, we'll be able to make m the subject and then we'll get the value for what? For m. Okay, so let's see the solution. Good. So looking at the diagram, we can write the general formulas. H squared equals O squared plus A squared. Okay, so our H is what? M. So M squared equals our O is what? 4 in the question. So 4 squared plus our A is what? 3. So 3 squared. So now we have 16 plus 9. And then this is M squared. So this one will give us 25. And then M squared. Okay, so finding the square root of both sides, we have M equals square root of what? 25. And then this one will give us what? Plus or minus what? 5. Okay, but we are dealing with distance. Okay, we are dealing with distance. We are dealing with distance. So with distance, we don't have negative distance. Okay, so in this case, our M will be equal to what? 5 and not minus 5. Even though the square of minus 5 will also give us what? 25. Okay, so you have to take note that we are dealing with what? Distance. So we don't have negative what? Values. So M is equal to what? 5. Now let's go back and look at something. You realize that no unit was put against the values. So once there are no units, okay, you will have to, your final answer, put units there. So 5 units, because it can take any of the units of what? Of length. Okay, it can be meters, centimeters, kilometers. The question did not state it. So anytime no unit is given, you have to put there yourself what? Units. So 5 units. If the units were to be there, you have to put the actual unit what? There. Okay, because it's a physical quantity, and every physical quantity should have what? A unit. When you measure, there should be a unit attached. Alright, so students, we'll end here and then we'll continue next time. So take these 2 questions as an assignment. Okay, take these 2 questions as an assignment. The next time that we'll meet, we'll solve it together, then you compare it with yours. Okay, till we meet again, revise, read ahead. Bye.